Is Abu-Saif. I'm a graduate student at the Biomedical and Health Informatics program here at the CHIP. And my project was about trying to predict readmission rates at hospitals for diabetic patients. So the data set I got was online from a source called UCI. And here are all my variables. I used the Tableau for pre-processing and changing all my variables and summarizing or simplifying the metadata. So, like for example, I had to summarize many of the variables, specifically like admission type. I had to narrow it down to emergency and urgent and not available. And age groups, there were like 8 or 9, so I made it summarized it to older than 30 and less or younger than 30. And also diagnostic groups here, I had to simplify it by code. There weren't any, it was all numeric by ICD codes, so I just converted them all based on their groupings, so based on system. And then afterwards, other thing was the specialty for providers. I also simplified it and grouped them. And the readmissions, it was 0 and 1, and I changed it to readmission or readmitted or otherwise, based on readmissions being less than 30 days after the last discharge, and otherwise is more than 30 days. So the program I used for analyzing was orange. So as you can see here, here's the layout. So to start off here, the statistics for the data sets were presented here, summarized, just for make sure that everything was transferred correctly. And then afterwards, I put the file in a table. Basically, as you can see here, which was visualized in Tableau. And then afterwards, I used the sampler to form my test and training data, being using the 85 cutoff for training. And the first part here on the top is basically I was trying to figure out which was the best model to use for predictions. So I used these 5, the tree, neural networks, random forest, the Bayes, and the regression. And then afterwards, I did some testing to see the most accurate ones. And as you can see here, the neural network and the logistic regression and the Bayes were the top 3. So afterwards, I did the confusion matrix also to further analyze the true positives and true negatives of each one by percentage. So as you can see here, these 3, logistic, neural network, and Bayes, had the highest numbers. So because of that, I just used or kept all 3 of them. And then afterwards, to further analyze the positives, the true positives and true negatives, we used the curves. And of course, everything under the curve is considered negative or with a lower sensitivity. And here's a color code for them. So logistic, neural network, and naive are the top 3 here, overlapping. So the second part here was actually analyzing data and forming predictions. So I used the top 3 models here, and using a sampler, I used the remaining data to predict. So here we have the regression, neural networks, and the Bayes, and then afterwards the predictions were seen here, and each variable was presented, showing the predictions for each instant. And then afterwards, the data, I put the predictions into a data table as well to have visual and to summarize them. So I started off with about 100,000 instances, and after cleaning them up and managing the missing variables with averages, it was about 86,000. So I also used the ranking node, and this node identifies the variables that are or basically the best predictors. So here I did it by top 5. So the top 5 here were number of patients, number of emergency, the length of stay, and diagnosis and medications. So afterwards, I wanted to visualize the data, and after trying several tools to do so, I was able to use these predictions and enter them into Tableau here. So to do so, I formed the first dashboard here, and this one classified or grouped the data based on readmissions by diagnosis and admission source. So here, as you can see, the largest blocks are basically the highest number of records, and the admission source of emergency room with the diagnosis of something in the circulatory system were the highest. And second one was admission source from a physician or clinic, 11,000 instances. So you can see the patterns here, and then also I wanted to group them by diagnosis, so the circulatory system as well, and other specialties. This is because I narrowed them down. So you can see the size can help you navigate. Of course, second one is the diabetic patients with like primary diagnosis. And here are the color codes for each one if you just want to visualize them. And the second thing were other variables that were considered more of the core measures. So I did those as well. And the highest number were the A1C that was not measured on admission, and time in hospital, which is length of stay, was about 3 days. And of course, readmission status and number of records was about 1,600. And here is the second dashboard that I made. This one is basically trying to look at the most common variables based on predictions and leading to readmissions. And so here basically was length of stay, which was known to be one of the strong classifiers. So here, as you can see, the average or the highest number is 3, so it's between 1 and 4 days. Length of stay means that that was the number of days they stayed before they were discharged prior to the readmission. And here I wanted to check out the demographics. So the largest one were age group older than 30, females, Caucasian, and readmitted, and about 2,253. And second highest here were African American, older than 30. So, and the last classifier here were basically these. This was very interesting. I made this one because I wanted to see if I put in as many variables as possible from the study, what will be my highest classifiers. And here it showed, see the larger the mosaic, the larger boxes means higher records. So if you look at, for example, this is 16 records, 18. So in this quadrant here, you have length of stay of 2 days, number of medications 11. So for this one, I used the top 5 predictors as shown here. So see, these were the top 5 predictors. So I used them for my mosaic model. And based on top 5 predictors, the most frequent ones were the largest ones here, as you can see. And for this one, for here, this was also the demographics one, but it was more on a larger scale. And for here, I used the numeric variables, which were length of stay, a number of medications that were administered during admissions, and number of diagnoses that they had, a number of emergency admissions, and number of inpatients. So basically means that number of inpatient admissions. So these also classify the predictors, or the most common predictors for readmissions. Having about a number of non-diagnoses being the most frequent, 30 medications, and length of stay, the highest number being 2 days prior to discharge. So this is a brief overview of my project. Please, if you have any questions, you can feel free to contact me at any time. Thank you very much, and hopefully it made sense and was helpful. Thank you.